Hello friends, welcome to Learner's Planet. Friends, this is our third session for basic problems on circles. In the first two sessions we discussed the basic terminologies and concepts. We discussed theorems even. In the last two sessions we are discussing the basic problems on circles. We have done so many questions. Now I am sure you must be getting a good grip on circles, right? In this session let's take some more problems so you don't have to refer any other book. If you do all these problems which we are doing in the sessions, then also it's enough for you for any competitive exams, right? So let's begin this session, and once again you are suggested to try the questions on your own. As the question appears on the screen, just pause the session, try it on your own, then only after just trying, then only you just see the explanation or solution, right? So this will help you in practice in better manner. Okay, so let's begin the session. In the figure, let's take the first problem. In the figure, O is the center of the circle. Find A plus C. Okay. Once again, from this segment, this arc, suppose this is AC. From this arc, this is the angle on the center and this is the angle on circumference, right? So this angle must be double of this. So if it is B, it has to be 2B. And if it is 2B, this angle must be 360 minus 2B, because the total angle is 360 degrees. So this must be 360 minus 2B. Now this and this. Okay, this is a quadrilateral. The 4 points of quadrilateral, it is not a cyclic quadrilateral. Be very clear about it, because the fourth point is not on the circumference of the circle, right? But this is for sure a quadrilateral. So sum of the four angles must be 360 degrees. So I have this angle A, then plus B plus C plus this angle is actually 360 minus 2B, right? Because this complete angle is 360 degree. This is B, this must be 2B, so this must be 360 minus 2B, right? And all of them will be equal to 360 degree. Okay, so A plus C minus B is equal to 0. So A plus C is equal to B. So A plus C, it is equal to B, right? The very basic concept that the angle at the center from the same arc is double than any other angle on the remaining part of the circle or at circumference, right? And we have done so many questions on this concept, so now you must be thorough with this, right? I mean to say. Now this question. In the figure, TP and TQ are tangents to the circle of radius 3 cm. Find the length of the minor arc PQ. That means we have to find out this length, right? What is the formula for arc length? Theta upon 360 into 2 pi r. 2 pi r is the circumference of the circle, and we just have to see the theta, that is angle made by this arc at the center, right? Now we want this angle. Okay, then only we'll be able to find out the length of arc PQ. Now POQT, it's a quadrilateral. This angle is 90 degree, this angle is 90 degree, so this 2 is 180 degree. That means the remaining 180 degree should be this 2. So this is 60, that means this should be 120 degree, right? So 120 degree out of 360, that means 1/3 of the total circle. Okay, radius, that's already given to us as 3, so I write instead of r3, so r and 3 is cancelled, so it is 2 pi. So length of minor arc PQ is 2 pi, and if it is asked major arc, then the total length is 2 pi into 3, that is 6 pi minus 2 pi, 4 pi. So major arc length is 4 pi and smaller arc length is, minor arc length is 2 pi. Okay. Now this problem, very tricky and interesting problem. In the figure, the equilateral triangle ACE of side 4 cm is inscribed in the circle. Find the area of inscribed regular hexagon ABCDEF, right? Now this is really an interesting problem. I have redrawn the diagram. Now I have the circle one hexagon that is inscribed in this circle, and one triangle that is in red line that is also inscribed in this circle. Okay. Now this is an equilateral triangle ACE. Dimensions of this equilateral triangle are given. Now just see one important thing over here. This is the center of the circle as well as center of the hexagon, right? Now suppose this is point P. Now this OP, and suppose this is point Q. OPQ it is an equilateral triangle, right? And this equilateral triangle has the length of the side equal to radius of the circle. So OP is nothing but the radius of the circle. So that's one important thing over here. And this hexagon actually it is a combination of 6 equilateral triangles that you can see very well over here. 1, 2, 3, 4, 5, 6, right? So there are 6 equilateral triangles, and side of each triangle is equal to radius of the circle, right? So if we know the radius of the circle, we can easily find out the area of this hexagon, right? That is a combination of 6 equilateral triangle. Another concept is, see this P, I suppose this is X and Y, right? PXY is a triangle which is given to us as over here ACE. Or you can name it as ACE, right? That really doesn't matter. I'm just discussing the concept over here. Now if you concentrate, this is just tilted diagram, so do not get confused. Over here it is rotated, nothing else, otherwise both the diagrams are same, right? So I'm just taking this into consideration, PXY. Now if you see this part, I just remove this 1, 2, 3, 4, 5, 6 because you might have understood that there are 6 equilateral triangles. Now I see 6 different parts. Here it is part A, B, C, D, E and F, right? Now this part, so this is an equilateral triangle, right? And this portion is half of this triangle. Okay, similarly this portion is half of this triangle PSO. Similarly this is half, this is half, this is half, and this is half. So precisely we have 1, 2, 3 full triangles or 6 half equilateral triangles. Getting my point? And in this hexagon we have 6 more parts. 1, 2, 3, 4, 5, 6. So 6 parts are inside this triangle and 6 parts are outside this triangle. So the entire area will be double than the area of triangle PXY, that is ACE over here, right? Because each triangle is divided into 2 parts. One is inside this bigger triangle and one is outside this bigger triangle. So if we know the area of triangle PXY and if we double it, we'll be able to get the area of the hexagon, right? That's very important, very beautiful concept. So just listen to the explanation very carefully. Okay, so if we double the area of triangle PXY, we will be able to get the area of this hexagon, right? Now triangle ACE or triangle PXY, both of them are same, and this is an equilateral triangle, so area of this equilateral triangle is nothing but root 3 by 4 side square. So what is the side over here? It is 4 square. So that is the area of triangle PXY, and double of that will be the area of the hexagon, right? As I've already discussed the concept over here. So it is a 2 into 4, 8 root 3, right? So no, see, hardly any paperwork is required if you are conceptually clear. This diagram is just for your reference. Otherwise in examination time you don't have to draw this diagram, right? You can work on the same diagram as it is given over here. Just match the points and you'll be able to get the same diagram, right? And area of this hexagon is double than that of triangle PXY. So simply you can solve it in less than 30 seconds or maybe 40 seconds. So the area is 8 root 3 centimeter square. Okay. I hope you are clear. If you are not clear for the first time, just see the explanation once again, but because it's really an important concept. If you understood this concept, you can solve this problem in 30-40 seconds. Otherwise, it will be really time consuming, or you may end up not solving it. Okay. Now see this problem. In the figure, the circle is inscribed in a regular pentagon. PQR are the points of contact. Find theta. Once again, very interesting problem. I suppose these 2 points to be O and say X. Right. Now triangle ORQ and triangle XPQ. OR is equal to OQ because from any external point the length of the tangent is same on the circle. So OR is equal to OQ. Right. And see, this is a regular hexagon. So XQ will be equal to XP and XQ is equal to OQ, since this will be the midpoint, right? So precisely OQ is equal to QX is equal to XP is equal to OR. That means triangle XPQ and triangle OQR, both of them are congruent to each other, right? So if they are congruent to each other, their angles will be same, corresponding angles will be same. Now this angle is theta, then this will also be theta, because that is angles in alternate segment are equal. This is the chord from the point of contact of tangent and circle. So this angle is theta, then this will also be theta, right? This is theta and XQ is equal to XP, so this will also be theta. If this is theta, again angle in this alternate segment are equal, so this will also be theta. And once again the triangles are congruent to each other, so this is theta, this is theta, and this must be 108 because this is the angle of this pentagon, right? And for a regular pentagon, each angle is 108 degree. So this is theta, and this is 108, and this is triangle OQR. So theta plus 108 is equal to 180 degree. So 2 theta is 72. That means theta is equal to 36 degree. Pretty simple. So what the concept we have used, angles in alternate segments are equal, and the angle of a regular, each angle of regular pentagon is of 108 degree, right? Now in the figure, AB is a diameter, find angle ADC. Pretty simple. AB is diameter, I match C and B. This angle will be 90 degree because angle in semicircle is 90 degree, right? Now in this triangle ACB, this is 90, this is 20, so total is 110. That means this angle must be 70 degree. Now ADCB, cyclic quadrilateral. So angle B plus angle D should be 180. If it is 70, it has to be 110. So angle ADC, that is 110 degree. Okay, 22nd problem. Now let's see this problem. In the figure, O is the center of the circle. If AC is 3, angle BAC is pi by 6. Pi by 6, that means 30 degree. Find the diameter AB. Okay, if AB is diameter, O is the circle, then first of all this angle must be 90 degree, right? Now this is 90, this is 30. This dimension is given to us and we have to find out diameter AB. This angle is 30 degree. So in triangle ACB, we know this angle and this length. Now relationship between this and this, that is perpendicular and hypotenuse, is given by sine theta, right? So sine pi by 6, that is sine 30 degree, is equal to sorry, here it is base, actually base and hypotenuse, so we need to have cos theta. So relationship between base and hypotenuse is given by cos theta. So it is cos 30 degree is equal to this base, that is 3, by hypotenuse, that is AB. Now cos 30 degree is root 3 by 2. So AB is equal to 6 by root 3, or we can say 2 root 3. Pretty simple. So if you know angle in semicircle is 90 degree, you can easily solve this problem. In this figure, PA is tangent to the circle at A. Angle CAP is 28 degree. degree and BA is equal to BC, find X. Okay, first of all, this angle will be equal to this angle. Why? Because angle in alternate segments are equal, right? This is the point of contact of the tangent, and from this chord, whatever is the angle which is being made over here, that will be equal to the angle in alternate segment, right? So this is 28, so this must be 28. Now this line is equal to this line, that means this angle must be equal to this angle, right? The sum of these three must be 180. So out of 180, 28 is already gone, so we are left with 158. I'm sorry, 152. So sum of these two is 152, so each of them should be 76 degree, right? So this is 76. Now once again, BAP, it is a triangle, so this is 28, this is 76 plus 28, so the remaining part is this. Okay, so 28 plus 28 plus 76 plus X is equal to 180. So X is equal to 48 degree. So if you know angles in alternate segment are equal, then you can easily solve this problem. Otherwise you will definitely stuck up. Okay, so your answer is 48 degree. In the figure, O is the center of the inscribed circle of triangle ABC. If angle OAC is 30, angle OAC, I'm sorry, it is OAC and OCA. Okay, one of them is 25 degree and one of them is 30 degrees. So the figure is correct. Here some misprinting is there. We have to find out angle ABC. That means precisely we have to find out this angle, right? The first thing is in triangle OAC, this is 30, this is 25, so total it is 55. So this must be the remaining angle, that is 125 degree. Okay. Now this line AO, it is passing through center, so when it intersects a tangent, this angle will be 90 degree because this part will become radius. So this angle is 90 degree and it will be a straight line. Similarly, this is a straight line. So here we'll get this and this to be vertically opposite angles. So if this is 125 degree, it has to be 125 degree, right? Now this is 90, this is 90, so that's 180. So 125 plus 55, that also added to 180, right? So this is a quadrilateral, so this should be 180, this should be 180, total 360. So 55 will be the correct choice. I hope you are clear. In the figure, ABCD is a semicircle, CDE, BAE are straight lines, CBD 30 degree and DEA 22 degree, find X. Okay, pretty simple problem. Listen to me carefully. AB is diameter, that means this angle must be 90 degree, right? Now on this line BC segment, this angle and this angle must be same. So if it is X, it has to be X. Okay, because angles in same segment are equal. So on this segment, this angle and this angle, both of them will be same. I assume this angle to be Y. Only this small portion I am assuming it to be Y, right? Now just consider triangle AEC. Since the figure is small, I'm just writing down the explanation so you'll be better clear. So in triangle AEC, this angle is 20 degree, this angle is Y, and X is exterior angle. So X is equal to 22 plus Y, right? Exterior angle is equal to sum of remote angles, interior opposite angles you can say. So X is equal to 22 plus Y. Right, this is the first equation we are getting. Then in triangle DCB, X plus Y plus 90 plus 30, that should be 180 because triangle DCB sum of angles should be 180. So X plus Y plus 90 plus 30 should be 180. So X plus Y is equal to 60 and X minus Y is equal to 22, right? Since we want x, so it will be 60 plus 22, that is 82 by 2, that is 41. Pretty simple. So angles in same segment are equal. That the only funda we have used over here, the only concept we have used over here. Okay, I hope you are clear. In the figure, ABCD is a semicircle, angle CAD is. Okay, first of all, what we do, we join D and C. Okay, now this is angle in semicircle, so it must be 90 degree. Now this line is equal to this line, so this angle must be 25. So if this is 25, this is 25, so in this triangle it should be 130 degree. Okay. Now ABCD, it is a cyclic quadrilateral because all the 4 points are there on the circle. So if it is 130, it has to be 50. Right. Now in this triangle ACB, it is 90, it is 40, so it has to be it is 50, so it has to be 40 degree. Clear? Maybe figure is not clearly visible to you, so I just explain. O is the center of the circle. This angle is 35 degree, this angle is x, and we have to find out x, right? Now from this segment, suppose this is AB, this is angle on the center and this is angle on circumference, right? So this angle will be double of this angle. Now this angle is what, 110, so the total is 360, so this portion must be of 250 degree. So if it is 250, it has to be 125. Okay, now in this triangle, suppose this is P, APB, this is 125, this is 35. So the total is 30, 40, 50, 60. So 160, so remaining part of the triangle must be of 20 degree. Okay, pretty simple. So we have used the same concept that we have used so many times, that from the arc, angle at the center is double than that of angle at any other part on the circle, okay, or on the circumference of the circle. So the same funda I have used over here. You must be getting a grip on this concept now. In the given figure, BCA is a semicircle, AC is 6 and CB is equal to 4. Find the area of the semicircle. To be able to find out the area of the semicircle, we require radius of the circle, right? Now this angle is 90 degree, okay, because that is angle in semicircle. This is 6, this is 4, right? So using Pythagoras theorem, we can say that is 36 plus 16. AB must be root 52, right? 6 square plus 4 square, 36 plus 16, that is 52. So AB will be root of 52, right? So area, radius must be root 52 by 2. So that is the radius of this semicircle. Now what will be the area of the semicircle? That is pi r square by 2. So I have pi, I have r, right? Pi by 2. Okay, so it is 52 by 2 into 2. So pi by 2 r square. It's actually semicircle, so it is pi by 2 r square. So pi by 2 and r square is this. So it is 13 pi by 2. Pretty simple. Now try this. EC is a tangent to the circle. Find angle CBD. CBD, that means precisely we have to find out this angle, right? First of all, this angle is 40 degree. That means this angle must be 40 degree. And reason is angle in alternate segments are equal, right? This is a point of contact. From this we are drawing this chord. So this angle, this chord, so this angle will be equal to this angle, right? Second thing, this angle is 65 degree. This is a linear pair, so this has to be 115 degree, right? Or this is 65 degree, that means this also has to be 65 degree. Okay, why? Because ABCD, it is a cyclic quadrilateral, so sum of opposite angles must be 180 degree. So this angle is 115, then this must be 65, right? Now do I need to tell you what will be the value of angle B? It is 40 plus 65, 105, so we are left with 75 degrees, so it is 75. Okay, so what concept we have used? Angles in the same segment are equal, the first concept, and sum of opposite angles of a cyclic quadrilateral is 180. Two concepts we have used over here, right? So many problems on the same concept we are doing, so now you must be getting the grip. In the figure, OXY is a sector with center O. If Z is the midpoint of YO, find the area of triangle OXYZ. Is to area of sector OXY. Okay, so for that we need to have the area of this triangle, right? Now we know the base. See, I assume the radius of this circle, this sector or part of circle is say R. So this is R, OY is R, and OZ will be R by 2, right? Now if we wish to find out the area of triangle OZX, then we need to find out altitude first of all of this triangle. So what I do is I just drop a perpendicular from this point to this point. So that is actually altitude of this triangle. Now suppose this point is P. In triangle PXO, triangle OXP, right? This is length R, XP we have to find out, and this is angle 30 degree, right? So relationship between XP and XO, right, that is perpendicular and hypotenuse, is given by sine theta. Here theta is 30 degree. So sine 30 degree is equal to perpendicular, that is XP, I assume it to be L by R, right? Now sine 30 degree is what? 1 by 2. So L is equal to R by 2. That means altitude is R by 2 of this triangle. Now it is easy to find out the area of this triangle, half base into altitude. So half base is what? R by 2. Altitude is also R by 2. Is to area of the sector. Area of the sector is what? Theta by 360 into pi r square. Here theta is 30 degree. Okay. So I divide it by 30 by 360, that is 1 by 12 into pi into r square. Okay. This r square and r square is cancelled. Then we have 12 by 2 for 4, 8 into pi. So it is 3 is to 2 pi. Okay, 3 is to 2 pi. Interesting and simple to solve. So your trigonometry should also be very good. This is just basic trigonometric concept I have used over here. Sine 30 degree is equal to perpendicular by hypotenuse, nothing else. So friends, so many sums we have done in this session. In the coming sessions we'll be taking more problems. Now I'm sure you must be getting a good grip, and you might have solved almost all the questions in this session on your own. Okay, if you are not able to solve, if you are not able to solve, then you need to practice a lot. Okay, just go through the sessions once again. I'll see you in the next session once again. Bye bye.